मॅडम 19 स्टार्ट करू आपण. Ma'am? Hello?
Yes, Rajni.
Yeah, hi, ma'am, you can start your session now.
Okay.
Okay.
Okay. Are you able to see the full screen? Hello?
Yes, ma'am. Yes. Yes, ma'am.
Okay. Okay. So good morning, everyone. Thanks, Rajni, for such a wonderful introduction. I'm Rekha Sharma. I'm currently in Toronto, living in California for almost 1 decade. I'm born and brought up in New Delhi, and I think you know much more from Rajni now. I think this is my second session. The first session I gave was more detailed in the grid optimization and what is generation and distribution and how EV comes into picture. Today, I will talk more about the optimization techniques and the big data and machine learning techniques that we are trying to use as an industry, and where we are right now and where we want to go 5 years or 10 years from now, and what the industry as a whole is doing to reach there. So to begin with, here is the agenda. We'll go basics of EV, like what is EV and what is EV charging means. Then I'll go deep down on the network management. This is what is happening right now. All the smart grid techniques that we have developed from last 2 decades in the industry, and how it is being useful right now, and how it will be useful to achieve the fully automatic grid and fully automatic electricity charging in future. Then I'll talk about the charging management system. This is fairly new technique. Not even everyone use it. Very few, maybe just 2 or 3 charger provider has that. It is nothing but a facility that every user has an app, and they know what is happening with the chargers in the network. They know what is happening with their car. It's nothing but your profile, like you have on the social media, right? Like Instagram, like your pictures that you upload. Same, you have a profile for your car, and for it has all the information about your charging. Then we'll go deep down on data analytics, what we are doing and how we're using the data right now, how much data we have and how we can interpret it, all angles of it. And then we'll go and see what machine learning is and how is it related to electric vehicles and what all we can achieve. So just as a fun fact, I added this picture for for the users to appreciate what a car looks like if you remove the upper body of any electric car. It's nothing but just a battery, how your inverter looks put together. It's lithium ion batteries. Here, where my cursor is, lithium ion batteries, joined in parallel with some space and I think some insulation in between for to avoid heating. And this whole battery pack is attached to the engine. It has a gear system, and just how your fan rotates, your car starts rotating. This battery pack is very heavy, but it's light enough that it can be used as a car. 10 years back, this battery pack was very expensive, very heavy. It used to have so much heat dissipation that the energy that it saves, around 20 to 30% of the energy used to get wasted just to cool itself. So then it was not an efficient system to use as a day-to-day car that millions of people will use. With great innovation in chemical, batteries, and with the industry mass production of these batteries in China and all over the world, we are able to uh, have big battery plants, and we are able to manufacture these batteries, and that's what is used right now. uh, there is a research going on uh, to have a solid state battery in future. If that is successful, then we will reduce a lot on the weight and on the capacity. That battery will have, I think, 20 folds capacity, and you will not we the problem that we have right now, the range, that problem will be solved. So it was just a fun fact, not going deep dive into the electric car design. We'll just focus on the data and the machine learning part in this presentation. So just connecting the dots from my previous presentation, just a quick reminder what charging is and what type of charging, and where we do the charging at what time. So I think in my first presentation, I went a little bit more in detail on the different type of chargers. So we have three very famous chargers. Level 1, 2, and 3. Level 1 is nothing but just a 120 volt, 20 ampere socket that you have. Like in your house, you just have a mixer grinder that you put it in and you use it. You can actually just take a cable and plug it in your car and it'll charge. It'll take forever to charge, around 30 hours to charge the car, but that's possible. The second, which is more popular house charger, is level 2 charger. It is 240 volt, a 40 amp charge. Most of the home charging, it is done by level 2 charger. It takes around 8 hours to charge your car, but if you charge every day, you can easily go to work, come back home, go shopping, do your everyday commute, and come back and charge your car. So it's very feasible. Not at all economical, because government subsidize the rates in the nighttime. Uh, I think before I go in the time of use, let me take the fast charging charger. That's level 3. It is a DC to DC charger, much faster than level 1 and level 2. It provides bulk of electricity in very short time, and it is used in most of the long distance drive that like a driver would do, that he or she needs a full 80% charge in just 20 or 30 minutes. Most of these chargers are installed near shopping malls or near some public place that you can just charge, maybe just go and take a bite, have lunch, and come back, and you will have your car fully charged, which means 80% charge. Just to give you some numbers, there are around 250,000 EV, which is 2.5 lakh electrical vehicles in California right now. And we are predicting that we will have 1.5 million by 2025, which is just 4 years from now. There are around 57,000 level 2 chargers and around 5,000 fast chargers. Globally, we are expecting that around 10% of the cars which will be sold in 2025 will be EVs. And by 2030, we'll have around 28%. And in 2040, we will have almost 60% of the cars which will be sold are going to be EV. So that's something which is coming, and maybe some of you already have a EV car, and some of you might get it in next 10 decades. Sorry, next one, like next 10 years. But that's something inevitable, and it will be economical as we go. But that's where most of the the industry is trying to focus, that how we can predict and how we can learn about future and get prepared, and that's the agenda, of this talk. Little bit on time of use and the tiered rates. So time of use is nothing but that in many of the utilities and governments, they give subsidies to encourage the electricity vehicles, because they feel that they are not there is no pollution, and there is no GHG, global warming, and all these terms that you keep hearing. EV is much better than a conventional car, and even for engineers and like scientists, they prefer electric cars because of the efficiency. So most of the batteries that we have, around 60 to 70% energy actually gets transferred into mechanical energy. On the other hand, for a normal car, it is much lower. It's around 20 to 25%. One advantage that you have over the global warming and other things is you actually get a better electricity rate just by having electric car. Government gets one tier down. So I'm not really sure about the place you live, but like for example in California, we have tier system. If you use certain amount, it's cheaper, but if you use too much electricity, the next year gets really expensive. But if you have EV, that is subsidized for you. So that's one more incentive that people are going for EVs, and that's where the figures of around 2.5 vehicles came. So this is just basic information of EV and charging and various things. Let's take just a peek on what happens in EV in a grid. Like, not look at it as a car, but look at it as a load or a generator. It can be used both ways. Just I think there is just one country which is able to do that, but it is possible. So let's look into the car as a component of the utility electric grid. So I think last time I went more in detail that you have generation, then you transmit the power, and then it comes to your household, and you just distribute. This is that zoomed in picture. Let's say this is your house. You have a solar panel in your house. You have an inverter, the battery as a backup, and you have few cars. So if you try to make a single line diagram for that, this panel becomes a deregulated generator. These vehicles and the battery, they become generator as well as the load. So that's bidirectional. The grid provides AC current, the alternate current, but in the house we're going to use DC. So this is just to peek that how you're going to imagine it in a network. Okay. I think I'll go deep dive on more technical now. So far, any questions? Are you able to follow here till here?
Yes, madam.
All right, thank you. So now let's go deep dive from this network to here. This is pretty much the whole grid, but not in generation, distribution, and generation, transmission, and distribution language. But think of it as a network of like signals and all the data getting transferred, all the automation which has happened in last like two decades. The smart grid, like the term smart grid became very it was like a fad in early 20s. But what did we do as a as a whole, as an industry? So first of all, I think first thing you must have noticed is your meter next to your house as upgraded as a smart meter. It used to be more magnetic before, and now it's nothing but a small piece of computer automated system where it's just taking measurements. So this is one component, but across the grid we have, let me start from the generators. I have hydro generator here, couple of wind turbines. So for all this, we have intelligence installed. We have meters installed there. We have sensors installed. If how much generation is happening, is every part working correctly or not? We don't go and we don't have to see and check. Everything has a measurement. Everything is intelligent now. We have a control room. One operator is sitting and just monitoring the whole plant just in that one room. Everything is digital, and like everything is computer based. If let's say fault comes, he's just going to get an automatic signal, and just sitting in control room, he can maybe turn that part off of the network. He can just turn it off so that there is no more damage, and like at their leisure they can go and check further. There is a lot of LAN used. If you've heard of SCADA system, so SCADA system is just supervisory control data acquisition. We keep acquiring data. We have a telemetry system where we are getting the data from power plants, from the loads, everywhere, even in the transmission system. Like, what wire is it? Let me just give you an example of like all the investment that we put in this grid. How do we use it? These transmission wires are miles and miles long. There can be one, let's say, from Gujarat to all the way till Mumbai. If there is a fault, how do I know exactly at what point fault occurred? There are relays for that, and we get automatic signal, maybe sitting in control room in Mumbai or Pune, that where the fault was, what happened. Did the wire break, or did it touch the ground? So all this signal comes every 4 seconds in the control room, and it tells you what is happening in the field. And that's how much precision we have right now in the field, that we know what happened, where it happened, every 4 seconds. So just to give you some terminology, not going too much in detail, that we have broadly classified this whole system in a few terms. EMS, I'll call energy management system. It's a system which is computer aided with tools. It is used by operators to monitor the grid and to control and optimize the performance of the generation or the transmission system. So anything in generation here, you look through EMS. Then there is a DMS. This is distribution management system. It's very similar. Like, I was in fact a part, like one of my employers, ABB, I was actually developing these softwares. It's very intricate software, too much coding there, but whatever we do in EMS, it's high voltage level. It's a 3-phase. And in DMS, distribution management system, it's just same collection of application to monitor and control the grid, but on the distribution level. So we're going to look into single phase power. We're going to look into lower voltage level. But similar kind of optimizations are used in EMS and DMS. The next interesting thing that we have developed is OMS, outage management system. Let's say there is a fault in somewhere. There is a transformer which just burnt in next to your house. Earlier, we used to pick up a phone, and then one person will come, maybe tomorrow or maybe today, and he'll fix it. Then he comes back. That takes time, and if we want the grid stability, we can't have these kind of outages longer than they should be. So we created this outage management system, which is again computer-based system used to monitor what broke. If a transformer will burn in front of your house, before probably that person will get a signal in control room that this is burnt. Now, when this happens, there are also some repercussions around the system that nothing else should burn. So there is an automatic relay system that just shuts off everything around. So it isolates that portion and it gives a signal. We also have this automatic signal. Let's say there is a van, there is this municipality person who has a van that he goes and repairs. He's already repairing in some other part of the city. He gets this automatic signal of the location where the fault has happened and when it happened, and whatever basic information the software can give, it will give. Sometimes it might not be a major issue. It could be just it tripped, let's say some circuit breaker tripped. Then means it's not a manual tripping. We can just reset it there. So maybe that person who's the the lineman, he is repairing something important and he doesn't need to come by and reset that. He can just reset it automatically through his software and focus on something which really needs manual work. So that ways we have we worked in last like 2-3 decades and made the whole system more automatic, and even if there is some manual fault, it is minimized to null. That is the whole focus. The next thing is market. uh, uh, Earlier, I think there was only one generator. There'll be one municipality who just creates who just generates some power and it comes to your house by the whole path transmission and distribution. But now it's a deregulated market in many places. You can just buy a power plant. You can, if you have enough money, you just create your own power plant and you just put it in the grid. And now it's nothing but just a share market for electricity, that I have a power plant and maybe you have two and there is another friend who has three. So there are 6 power plants. There is this market which does automatic optimization to see I need so much power, which one is giving me the cheapest? And also which is making sure that none of the lines in the network and none of the components is going to be overloaded. Like I want to get power from places which are close to my houses and they are cheaper, and also there is the optimization is also taking care that nobody is making too much money. It's still a regulated market, but you can come and be a player, like if you want. Like you can just have your power plant and you can it's a private firm and you can make money. Then I think I already spoke about SCADA. It's nothing but acquisition of a lot of data, and that data is used to make decisions. Like we take the SCADA, that's rough data, and then we like SCADA is, I think, everywhere. Like I'll get data from the each user. Like I know how much in each house, how much electricity is consumed at what hour. We have the whole like profile. So we also get this as an input to plan how much generation we have to have, like tomorrow or at the same time, at the same season, how much electricity I want, so that I can get my power plants up well in time. There is no delay, and that data has, I think, helped great deal. I think there are more details in that, but for this presentation, I will not go further in. Okay, now let's just focus on something that is the focus of today's talk, is EV charging. This whole system, the network management system that I explained, it has this newest component, which is a charging management system. it is again a computer-based system, but we have just in the parking lot, what all components are there which are either consumer of power or they are going to provide power or transfer the power. So I have a meter to measure all that. I have LAN to give the signal here and there, and I have I have charging poles, and then a car might be plugged in or a car might not be plugged in to get some electricity transfer. So how do I know? There is this intelligent system that has been developed that every time a charging is done, we get signal through this LAN in the change management system, and then it goes to the database and it goes to the provider. So you are just there is a pole, you just go plug your car in, and the provider gets to know that you're charging, and for how long you're charging, for how, what kind of load is this charge giving. So this is a real time, again, like system. Every few seconds we get this data. With 4G, it is this fast. We have to see what happens with 5G. Maybe this 4 second might just become a fraction of second, and then we can control the system much more than what we can right now. Because right now also, even with every 4 seconds I'm getting the data, I have to take a buffer, because by the time it reaches the control center and by the time we can react to it, means not we, but the computer reacts, something has to happen, some other generator has to get up, there is a few minutes lag. And like, as I think everyone know, electricity cannot be saved at any point. It has to be generated and it has to be consumed. So it's a real time equilibrium that we have to develop, and having this communication is it's very helpful in that balance, the energy balance that we are trying to do. So I think I'll give you a minute to look into this, because this is the base. We also have this solar panel, that because most of the charging station might have a solar panel next to it, that's their free electricity which is coming. So they just get all the electricity when from the solar panel when it's sunny, stores it, and whenever the car comes, this is used. Otherwise, they can always take it from the grid, and that is definitely charged. So I'll just give you a few seconds to absorb this information, and then probably in like 2-3 seconds I'll move on. Okay, so let's go. So why am I doing all this? What can I do? Like, how can I use this information? First thing is, if I know how many cars are there, I can better optimize that I provide power to everyone. If I don't have this dynamic load balancing, if too many cars get connected, I may not be able to give power to the last one which is connected, because it just goes in a series, that the first guard get connected, and then whatever is left goes to the second, then the third, and then the fourth one doesn't get anything. But if there is a load balancing, I'm not going to give whatever the first car is asking. I'm going to balance it out in all the loads, which are, means all the cars which are loads connected in the network. So that is also possible with this kind of automation and smart features that we keep adding in our chargers. And this is a charger feature. It doesn't even need to give all the information to the SCADA and all that. This charger itself knows how many components are added, charging at any point. I have 3 cars or I have 4 cars, and then it can distribute. So this is a property of a charger, that it can do this load balancing. Let's see what more things we can do having this intelligent system. So we have also called this as automatic alert management system, AMS. Since I know all this information, it is very easy for the charging network to know which charger is faulty. Let's say for the whole city, your company has 1,000 chargers, and one of them is faulty. Means you're not going to go and check all 1,000 of them all the time, or you're not going to have a person keeps checking that. You will have an automatic, means you can have an automatic system which just tells you if there is a charger which is not working and why it's not working. The same thing that the example that I gave for the OMS system, if a transformer is tripped or there is like a fire, the similar kind of thing can happen in charger as well. Okay. Hello, I'm sorry to interrupt. I think someone forgot to. Hello.
Deepa Bhandare madam, please. Deepa Bhandare madam. Just a minute, madam. I'll inform her.
Okay. All right. So, all right. Okay.
Ma'am, you can continue.
Okay. All right. I just want to make sure that everyone can hear properly. So okay, so we were going that if you have 1,000 chargers and one of them is faulty, you're getting to know automatically which one is faulty. And maybe again there is a very small like automatic restart is to be done. Why you want to hire a person, go there and get it repaired when something can happen automatically. And that's the beauty of this AMS. We are reducing the time of technician, and we are having him focus on the more important and more intricate tasks rather than just doing a work which can be done automatically. Statistically, we have seen around 80% of the problem have been solved automatically so far, if we have detected and tried to uh, uh, fix the problem automatically. Now, this is something that the owner of the charger system will have. Um, is there anything else that we can use? Yes, of course. We can do for fault detection and for just monitoring the whole charging patterns. What, which charger is up at any point of time. Let's say I have an app in my hand and I have the charger of this company, let's say ChargePoint, and I am in an area that I am not really aware, it's not close to my house. I can open the app and I can find out where the nearest charger is. Is it faulty? Then I won't go. And is it free? Maybe in some shopping mall, this company has 10 charger and all of them are occupied. So I know that if something is occupied for next 30 minutes, I'm not going to get it, minimum 30 minutes. So maybe there is another mall just 1 kilometer from this mall, and there is 2 or 3 empty. I would rather go there. So I as a user can also optimize and get more information about the charger, the distribution, what is available, what is not available. For the company, I think it is a valuable information that every time I plug in at any location, I get like company gets the data. What time I charge, how frequently I charge, do I charge every day or maybe over the weekend? Am I charging only outside in the DC chargers, or mostly I am a person who charges at the at home, and at what time I start my charging? All this information my company can have, the charger company can have. It also can have the history, like if I just charge somewhere very remote, every data is there. Also, I think it also have my history and it has the charger history. So let's say tomorrow I sue them that I charged my car, there was some problem in this charger, my car is not working or it just overheated, something. They will have all that information. So that can be useful, that cannot be useful, but I think most of the most of the time it is valid information, useful information. It also have a driver information, like like, is it my car? If some car is going, whose car is it? That profile information is there. uh, that also is very useful in theft detection. Just like, how you have iPhone, and if someone steals the iPhone, even if you just turn it on, you can locate the iPhone anywhere. So similarly, if my car is charged somewhere, I know what point it's charged and the location of the charger. So that also can be probably used someday. So this is just the basic idea. But then let's say I get all the data. How in a different way I can use? I think I can let, now think from a perspective of a company. I have some 5,000 people who are using my charger randomly. Can I just use all the data that I'm getting from these 5,000 people, 5,000 cars, and try to make some trends? Can I see what is the time that most of the people charge? What is the time that nobody really charge? All these kind of things, hourly profile. So we did actually hourly profile, and we found out that around 5:30 there is already like all of a sudden there is a load spike, and then again there is a load spike at 8 p.m. By load spike I mean that a lot of chargers just starts charging, and then again at 6 a.m. So we try to just get this data and try to correlate some data. So I think right now, in this slide, I'll just focus how I can profile this data, and then maybe in near future, I'll in the machine learning part, I'll go how we can correlate and interpret. So one is this hourly profile. The second is the location, like in the residential chargers, what is the time? In the malls and the public places, what is the time that that is more frequent? And in the workplace, in the offices, it might come very intuitive to you. You will say, of course, I know in residential people will charge in the night, and in the workplace, of course, 9 to 5 work hours people will charge. And in public area it might be random, and Saturday Sunday maybe there will be more public charging. So this is very intuitive. But sometimes just by gathering all the data and doing the analytics on that, we actually come to conclusions which are not intuitive to us. Let's say this, for example, this 5:30 p.m. It was not at all intuitive to us when we did the data analysis. And for your surprise, 5:30 p.m. was the residential load, peak. And we were confused, but we just then, of course, it's logical. Most of the people maybe in this location, in this city, small city, takes only 15 minutes to reach most of the house. It's a very small city. Then people start at 5 o'clock, they reach by 5:30, and they start charging right there. So those kind of correlation are they can be done by all this data analysis. So this was not intuitive to me initially, that people might be charging at 5:30, but I thought maybe they'll wait till 12 o'clock, that when they're actually charged, their utility will be very cheap, and that's when they'll start charging. But no, most of the people are not waiting till 12 o'clock. They just go plug it in and that's it. So that also gives the opportunity for us to see potential enhancements that we can do in our industry. Like, can I give him a feature that he doesn't do at 5:30? Can I give him something that maybe he's lazy to come back, come back from his couch or bed at 12 o'clock? So we start thinking in that terms. Just by looking at the data, we try to solve his problems. So let's go more deeper into the charger types. What are the chargers? Like, are people really charging in level 1 or level 2 or superchargers, let's say Tesla ones? What is the most popular? How can I use this information? If I know people are really charging in level 2, if I'm a manufacturer, why will I waste my energy and my factory and my resources to even manufacture level 1? I will want to make most profit where most of the customers are buying level 2. So I will probably just make level 2 chargers and put it in the market, and I get all the profit. So many even manufacturers can do this data analysis and learn something from it. Now, outdoor temperature. So there is this there was a theory for battery that in cool it discharges fast and charges fast, but we were not really sure what will happen with car, which is true. Like looking at the data, we did some test in high up North Canada and low in Texas in US, and it's different. People don't charge that frequently in Texas that they do in up north. Given just same volume, so we have to find the data set which has the uh, same number of users, similar kind of profile, like working professional, going from 9 to 5 job, all those kind of data sets, and then we see how often this group charges and how often my Texas group charges, like how often Canada group charges and how often Texas group charges. And because I know demographically these two places are different, like one is very cool and the other one is very hot, so we can do some analysis, and we have successfully proven that people in cooler area have to actually charge more, and unfortunately they have to charge for longer duration. Now longitude, latitude, it's a very basic thing, but think like just for the longitude and latitude, um, there are some places that it's daylight all the time, and there are some places that it's dark after 4 5 o'clock. So does that make a difference? Because if it makes a difference that in a city where it gets dark after 5 o'clock, maybe people will rush at 3 o'clock or 4 o'clock to just charge the car, or maybe they will do it in the morning, 7 o'clock or 8 o'clock, they'll charge the car. But if you have sunlight till 8 o'clock, why will you wait? You'll just do your job. At 7 o'clock, you'll go to a supercharger and charge. So see, the demand for the electricity changes just by these variations. Then there is this sixth item, which is very technical. It's the state of charge, but I think it's very important for every user to understand what it means. That state of charge is how much you are already discharged. That makes a difference. Like most of the car manufacturer, they advertise that every day you go home and you charge by your level 2 charger at your home in the night. That's the most ideal condition for everyone. The electricity is cheap, there is no problem for means I think for the load, so everyone just publicize that. But on a long trip, what will you do? Will you go all the way down till 5% of charge and then you find a charger and you charge it? Or as soon as you hit 20-30%, it'll charge? And we saw that there is a difference. The lower you go, if you go lower than 20%, it's actually damaging. Like it takes, not damaging for your battery only, but it takes like really fast. Like battery will charge really fast initially and then it slows down. And if you charge after 80%, like if your battery is already 80% charge and you put it to charge, you want to just make it 100%, it takes forever to charge from 80 to 90 and then even more from 90 to 100. But then as soon as you start driving, it just shoots down so fast. So the amount of electricity that you used to go from 80% to 90% and then to 100%, you took so much power. But when you started actually driving, in just 10-15 kilometers, you're going to use all that. So do you really want to spend that much money to just waste all this energy? Because it's just not means it's just inefficient. So this, we are trying to educate all the users for the cars that what is the optimum range. It's 20 to 80%. Don't wait to go to 2 down, and don't be greedy to go to make it 100%. 80% is good enough. You don't need more than that. So I think those are the ways that you can look into the data. Like you're getting data like in the previous slide here, and what all are the factors, like different style of formatting the data. So this is just a picture. I put it here because so that you know what we do. Like we just make bunch of graphs and pie charts, but it actually helps us make decisions. Like we have in this blue chart in the left, we're showing that how much is the kilowatt of energy consumed at a station in last 7 days. So this is one station. So we just took some 35 stations and we 35 locations, and there were some 190 chargers, and we saw what happens on Sunday, Monday and all that. So we see, oh my god, Sunday everyone is charging, Friday, Saturday no one is charging. It might be useless information to most of the people, but if I am the person who has to generate electricity for the whole area, this information is very useful, because I will be ready that these people are going to come and charge, and I should have electricity ready for them. Or maybe I will use up all my solar and everything in a bigger battery, so that there is no imbalance in the grid. So I think I'll take a small pause here. Any questions so far? I'll give you like 1 minute to look into the data. I can go on and on, but I think you got a feel that what all we can do with data so far. So take a minute, and Rajni, are you able to listen to me still very
Yes,
well?
ma'am. Yes,
Okay.
yes, ma'am.
All right. So yeah, take a moment, and for a company, I think you see these last 7 days, you even know how many people called you, how many problems were there, and how many got solved. So all this can be just in one screen. You have so many so much information. You can go by daytime, nighttime, which city, small city, big city, populated city. You can just see how people react, and what we have to plan in a bigger picture. Okay, moving on.
Hello, ma'am. Hello,
Yes,
ma'am.
yes,
Alesh Patel sir is asking about can vehicle be charged when it's raining or snowing?
yes, yes, it can be charged.
Okay, ma'am. You can continue, ma'am, now.
Okay, so again, I think maybe the picture didn't come out right, but this is per user. Let's say is this orange bar is just me every the whole week. What happened? Did I charge every night? Oh, Monday to Friday I charge, but Saturday I didn't charge. Why will that happen? Because I didn't go to office, right? Means correlation. I didn't go to office, I don't really need to charge. Maybe I just went and grabbed myself some sandwich and I just used up a little. So all these like data charts and pie charts, we know how much usually a person charges, how many like in the whole year, what is the pattern. This whole can be analyzed like analyzed by these graphs. And also, like, am I charging at home? Sometimes I don't charge at home and I go and charge into other stations. What is that station? That also profile I have. And then how much money I'm spending per month or per day just to charge this. And in fact, I think there was one graph even to compare. There were two cars. Let's say I have two cars and I'm just driving same amount, and I have one is a normal electric car of same price range and same horsepower, and I have EV. So how much money I will save per year? Many cars actually do advertisement based on that you're gonna save money. There is a upfront, there is a charger money, but then in the long run you're gonna save money using electric car. Okay, so this is good. I'm I'm using so much data as the grid operator, that okay, I can do profiling and I can understand what my charger is doing. If there is a fault, I can fix it. So that's very useful to me if I have the charger, like if I'm a owner of a charger, or if I am an operator sitting trying to uh, give power to the whole state. But then why will my customer use it? He'll be like, I'm not downloading this app or anything, just you know I don't want to do that. But then there are some advantage even for him. I think I mentioned one. I personally have used it, and it's very useful to see in the whole map where are the chargers, which ones are free, and also sometimes they even tell you which ones the rates that various charger they have based on the location. Because just to give you some background, this is actually a big project which is not means which is not done right now, but there is a potential that in the whole, let's say, city, uh, there are so many, like, just imagine there are so many points in this city which I call node, and there are some points out of those which are pricing nodes, that on those nodes I'm going to calculate the price. So the price of the electricity at my home might be more expensive than what is in your home, or my teacher's home, not my neighbors, because neighbor might be getting the same, because it's in a zone, it's like a small pocket that I'll have the same price. Because depending upon the location, depending upon uh, how many users are using at that time, and how is my close by generator down for some reason and I have to take the electricity from far away, so there might be congestion on the way that I have to pay price to, so I'm getting very expensive. So if I have a mall, or let's say a shopping complex where there is a charger, and if I can given, so I have a data of my price rate, I have a data of my charger. If I plug it together, and that's my project actually, if I plug them together, can I tell my user which one is cheaper? Because if my house is there, and if I just drive for 10 minutes and I find a much cheaper charger, and I am charging 70% of my battery, I can just save maybe $5 to $6 just in one charge. So that kind of level of optimization would be very useful to the customer, like information also, and financially also you're going to get that. And can I tell the customer that don't charge right now, it's very expensive, and then maybe sometime in the day it's very cheap. You won't believe that there are some days that in the daytime there is so much solar and it's windy also, that electricity is almost cheap cheap and even zero at certain pricing node. But since it's regulated market, uh, that benefit doesn't go to the end user, the that company, the electricity provider eats up that. But just to make you feel better, they also eat up on they also have to bear the losses in case the electricity is very expensive in my house. I'm going to get pretty much the same bill. So monthly bill. So is it possible to uh, have some profit sharing, that if my location is cheaper, then can I go and charge and make save some money on that? So there is a project going on that also. One very small advantage, and I think not small but very easy, which is done even now, is the automatic payment. I can just, like for a Tesla user, you'll have an app, you find out where the charger is, you go plug it in, and that's it. There is no card swiping, there is no one sitting there to take cash from you. You just drive out and you have a either you get a bill automatically, which you have, like card attached, and that's it. You don't have to worry about the payment, everything is done automatically. But that is possible because that charger knows when you came, how much was the rate, for how long you charged, and then it is connected with your profile, and then you get charged based on that, and your credit card is attached to it, and then you get paid. So it's a convenience as well. Now let's take a deep dive on the data analysis that I wanted to share. I think I touched upon the correlation that I wanted to do with the data, but like imagine like why there are so many cars in LA, why there are so many cars in San Francisco. Right now the density of the cars, if you just plot by density, the maximum number of cars are in San Francisco. So is there any correlation with having the EV factory, the Tesla factory in San Francisco, or why there are so many cars in Netherlands? Because is there any correlation that their electricity, they are fully renewable and there is no cost? So all this data analysis can be done by data, like how I said that we can segment our data, like give me the list of all the factories and then superimpose, give me the density. So I can superimpose my data, like just uh, by those how can I say, um, in an easy language. I think in the just the scripts that we write in our Python and all, we can superimpose by layering. Okay, so we can do that and see. Let's say there are 10 cities which has factories. Are these 10 city my top 10 dense uh, mm, uh, dense car, like electrical vehicle density? So if it comes yes, 8 of the cities that has electric factories are actually dense. So there is your correlation, right? And also like we can just see the distribution, which city has most number of cars. Maybe there is some government rule that came in. There is a policy that government said that no, from there is a subsidy to some kind of car. Let's say means we were able to prove this, that in California there was some $2,000 or $3,000 that you get tax credit. So everyone just thought it's a good opportunity to save some money on tax credit. California also gave some electricity rate discounts. So of course it is very natural for the user to go and buy that. At the same time, let's say Missouri, they don't give, in fact they penalize in a way that uh, uh, you have an option of renewable energy to have a solar plant and all, uh, but it's expensive. Like who's going to do that, right? Like if you can get electricity from a normal means by 25 cents per unit, the renewable will be 45. So that is kind of discouraging for the user to go for renewables. If you don't go for renewable, of course you will not go for EV also, because the whole concept is very related. So these kind of correlations can be done. I can see what is the density of all my cars, and then I can see where I have to market my chargers. If I'm just a EV charger factory, like manufacturer, I know where to sell. Why do I put up an ad of a charger in Missouri when I know nobody has EV, right? I should go and target. So it is also like this business, the MBA people, they also use this big data analytics to even do some marketing uh, tricks, so that if it's quite highly probable that a person who will walk into a Walmart will either have a electric vehicle leasing or buying, or is probably thinking about it. So let me give him the advertisement of this charger. So those are the tricks that marketing people can apply. So I think one of the biggest use that we as an industry, like not marketing people, but as a whole industry, what we are trying to do together, many companies, that we are trying to predict how many cars are going to be there in 5 years from now, and where, and by what volume, and how many of them will use level 1 chargers, level 2 chargers, or level 3 chargers, so that we can work on making them, right? Like you should have so many chargers to support so many cars. So that is a very big effort, and I think it's a very useful and fruitful effort, which will help the end user. Um, one more which is very useful work which is going on is that many utilities are actually hedging on the patterns, where people are charging, what time. Like I said, at 5:30, that became a big problem. Why at 5:30 I want my people to charge? That's the time when solar goes down. And that's the time everyone goes home. They start plugging in their car, they start plugging in their TV, and they start cooking, and everything is up, AC is up. So electricity demand is so high, and if the car is also charging at that time, it's just uh, becoming a burden. Can I just make some optimization that I'm not giving a burden to the person? I am saying, you plug it in, let it be idle in your house. At 12 o'clock, automatically, I will start the charging. Right now, I think there are only few cars which has this facility that you can plug it in, and 12 o'clock automatically it will charge for 3 hours and it shut down. Or 12 o'clock it will charge and it will charge till 60% of your battery and it will stop. Something like that. So hopefully, if more and more cars have that feature, the power supply problem can be solved. So that kind of data analysis means this data analysis will be very useful in handling that situation. um, then I think I already covered the load balancing, that instead of 5:30 you do it at 12 o'clock or 2 o'clock, even better, when everyone is asleep and I have just some free wind coming in. Um, I can just charge your car for free instead of becoming a burden the grid. So give it a thought. I think it's an interesting idea how just having so much data, we can predict models and we can even see where the industry is going and how it should be going. So so I talked a lot about the data analysis and big data and everything. So just to clear up the air, big data is nothing but just data in big volume. We have Oracle as a database, which industry is using for years. There are cloud-based structure coming in, which is coming very it's becoming very popular. I am just digging down in a new thing which I just learned, Snowflake. It's a whole architecture on cloud. Many people are trying to use that because there is scalability, and it is it's going to be very fast. There won't be any queuing and any delays in there. So just a segue on the databases. So let's see the forecasting piece. I've been telling that I use this data and I will predict future. I will use this data and predict future. Within this, using this data is the data analysis, but predicting the future is the forecasting, which is a different field altogether. Just to explain some basic, we can have this is the normal mathematical analysis that we have. If let's say many people, it means I think government use this, right? Like the rate of population which is growing. We'll just plot the graph. The simplest is just have a straight line, which I think nobody uses, but mathematically, yes, it can be used. Mostly in sciences, we use statistical models. To predict the data, we have weather data and all the information coming in. We know how much is the load, and we know how much consumption is going to be there on any day, like Friday, how much people generally use electricity. We even have some histographic data that I keep collecting data, and then I plot a graph, and I just extend it a little bit for next maybe 1 hour or two, to predict very accurate data in the same load curve. There is one more feature that I think I lately used in just last 2-3 years is the persistent model. Persistent model is very simple. Let me just read it out, the bookish definition. The persistent method assumes that condition at the time of forecast will not change. So imagine you are predicting very close by just what will happen next minute. You can very much assume that however you are now, the same thing will be there next 1 minute. So you just plot in the same, same direction. So these are just basic tools that I wanted to touch upon in this presentation, so that you know the difference. There is a data analytics and there is a forecasting, and I want to use both of them and be useful to our industry. Okay, now let me try to explain this, that how we can have analytics and forecasting together. So this is an American graph, and anything which is red is that we have chargers right now, but we don't have enough chargers as compared to 2025. Anything which is blue, so let's say I have 100 chargers now, and in 2025 also I will need only 100 charges. I don't need any more. So I have almost to the capacity. So I use the prediction model here, that to calculate how many charges will I need 5 years from now, given how many people are buying the cars, how many people, what is the age segment, because we also saw that mostly like uh, uh, 30 to 50, that is the range, that is the most you means those are the people that use the electric vehicle the most. Anyone beyond 80 is not. It could be just psychological, they don't like changes. But whatever the reason be, we can go by demographic and we can predict that this city is my potential customer, that okay, they will buy EV, they will even buy chargers, and the whole infrastructure will be there, needs to be there in 5 years. So I can do this whole modeling and I can tell New York is my market, Los Angeles somewhere that I need to go and install some chargers. This is the whole country map, but I can zoom in the Los Angeles and I can tell where exactly, which pockets, and then we can go and install. And that will be most profitable for any company, and also for the customer. It's not only about the profit for the the people who are putting the chargers, but also convenience of the customer. Okay, so this is just an example how a company can have a strategy just based on the analytics. Okay, so I think we are doing right now, I want you to imagine what we might be doing or what we should be doing in next 5 to 10 years. So this is one basic thing that we can do. One is that with the AI, can I, based on this data that the optimal charging time, can my car just automatically starts the charging? Right now in Tesla and other cars, there is this feature that I can program in my app that it starts at 2 a.m. But car doesn't start automatically. Means it doesn't start charging automatically. So can we do this, that car will be so smart, like it will have all the we'll put in the machine learning in that car will read all this data, will analyze this data, and will say, okay, at 2 a.m. this is my very cheap rate, and I'm starting charging. Given that the car is plugged in, like I come in from office at 5:30, I charge in. I did not tell the car to charge at 2 a.m. The car has this learning, the machine learning software in it, that it can assess that this is a cheap rate and I'm starting, or whatever parameters that we want. We can program it that uh, mm, do when it's not sunny, something. We can just put in some learning, machine learning, and it does it automatically, not by setting, what I mean. Okay. The next is think with the AI on the location. Can car automatically find the cheapest car charging station in 5 kilometers, and it just starts automatically navigation. So finding the cheapest charging station, that can be done easily. uh, Navigation is done in the car easily, but the car should have this machine learning capabilities that it finds itself, automatically starts by my voice command. Maybe I'm just driving and I just say uh, um, go charging. That's it, that's my keyword. I say go charging. Now my car will go look around in the map in 5 kilometer or 10 kilometer radius, finds it automatically. It just starts navigating me. It just starts, giving me ways that turn left, turn right, and it takes me to the place that I'm supposed to charge. So that's a very doable, feature in the car in next 5 years. Um, Now this third one is it's a long run, but I won't say it is not possible. But it'll be interesting to see when this happen. That with the previous two, the machine learning features, can my car drive itself? It's not navigating; it's just driving itself to the best charger, to the cheapest charger, and then the charger will have a robot. There are some chargers which has bots right now, but not very functional. That my car will automatically go park itself in a charger. The charger, that whole area, senses the car, and there is a bot, the robot. It takes the charger out, plugs it in. My car starts charging. When the charging is done, the bot takes whatever the plug is out. My car comes back. This is the dream. I would say this is um, the vision. Okay, this is where we should be going. To get this, to get to the third part, the self-charging one, we need self-driving cars. We have some self-driving cars, but the best we have is which can drive on the freeway where there is no traffic light or stoplight. So that is a concern right now. We means if the car doesn't drive itself, there is no point of having that AI in the car, in the intelligence. So this is a long shot, I said, but we'll see when it happens. But then I think pretty much I covered all the technical aspects I wanted to cover in this session. But think about AI, but with a grain of salt. Nothing comes with problems. I think one technical problem with this AI is that uh, it's very expensive to have a bot for the charger, to have a self-driving car, to have that kind of machine learning. It takes a lot of computing and a lot of network, like 5G has to be successful, and then so many things have to happen, right? Which is millions and millions of dollars, and like human investment, time investment. So it has a high cost. It has a risk. Someone can hack my car and just take it away. They can be thieves, or they can, worse, they can just go hit someone, and that becomes a legal problem. One very rudimentary risk with any automation or anything which is people are afraid that what will we do if the machines are doing everything? What am I going to do? So there is a risk of unemployment. Then there is a privacy threat, like I'm giving all the information, my house, what time I'm charging, what time I'm sleeping, where am I going, where is that where did I even have my lunch, because I'm going to the mall charging my car. So everything is out there. in all those graphs and everything, people know like the same problem is happening even with Facebook and with Instagram. Your privacy is at threat. uh, uh, Given all this risk, but after all, humans are humans. Human are adaptive learning, means we grow, we become intelligent. But machines, we will, machine learning is nothing but we're just going to put a program, right? Like how you put hello world, it writes hello world. If I'm going to tell my machine that if the electricity rate is cheap, charge, that's the program I put in. And with the given parameters, she's not going to program herself. Okay, so that is always a limitation of AI. It's, after all, it's just my programming. So I think that's all from me for today. Thank you very much for listening, and I hope I was able to, convey something interesting. I'm open to questions.
Hello, ma'am.
Yes.
Hi, ma'am. For initial few minutes, energy storage devices draw an impulse power from charger or grid. In that case, how it will affect on grid stability? Question asked by Godse sir.
So let me try to understand again. So can you repeat once, please?
Yes, ma'am. Uh, for initial few minutes, energy storage devices draw an impulse power from charger.
Mm-hmm.
In that case, how it will affect on grid stability?
Yeah, sure. I think it's a valid question, and I understand where it might be coming. The same concept is there when you start a car, there is a surge. But we have surge protectors, we have capacitors in the grid. So that is handled very well with that protection. So I think that's the thing. Like we have surge protectors and we have capacitors in the grid. So frequency never fluctuates.
Okay. Another question, are there any additional earning opportunities that come with EV charging stations? How do you pay for EV charging?
How do I pay for EV charging? Additional, what? Additional what?
Additional earning opportunities that come with EV charging stations. Question asked by Patil sir, Alish Patil sir.
So Patil sir, can you elaborate exactly what you're trying to ask?
Patil sir, please unmute yourself. Can you hear me, Patil sir? Okay. Okay. Ma'am, please tell me, are there any additional earning opportunities that come with EV charging station?
Oh, so what do you mean by earning opportunity? Like for the person who owns the charging station, what else? Like what more money he can buy, or for the person who's charging? Like who's earning money here?
The person who is
Good
charging.
morning. Good morning.
Huh.
I am Avdut here.
Hi, Abdul.
Yeah. Can I change a little bit the question? Like, what are the business models generally run in America so that many people can make money out of it? Uh, for example, who is the investor and how the charging station manufacturer makes money, or
Oh,
if I have
okay.
my own places in different areas, like if I have dhabas or roadside hotels and all,
Mm-hmm.
then for example, now progressive education society, modern college, themselves have many places in Pune. If
Mm-hmm.
modern college of institution, if they start thinking to put up charging stations because they have their own land, as well as
Mm-hmm.
if they have their own infrastructure, and that too there are many students are going to come, many professors are going to come in their areas, can they make
Mm-hmm.
money out of it?
So yeah, very good question. In fact, that's what my whole project is about. Um, So honestly, it's not a proven fact right now. Yes, people are making money, but most of the people are making money by selling the home chargers right now. So I have few friends who have started their company. They are mechanical engineers. They just manufacture those home chargers. That's what is, that's what has been proven profitable. uh, Most of the chargers right now, like in US, either they are solar powered. So you might go to a park, there'll be a solar power plant just put up by a power, which will be probably free for you. So there is no money incentive there. It's just solar power will be there. So it's just like when you go to shopping, you just get it charged. It's generally done by municipality also, so there is no money there. Second kind of chargers are paid chargers, but those are also like in offices. So many offices in Bay Area will have chargers which company will be paying that. So they are actually put up by the electricity provider, like who's actually providing you electricity. They have just put in the like socket for you, and they are just charging how you use, let's say, fridge in your house. They charge you same way they are charging that. So you just become an electricity provider there. So one person probably who's charging little bit more is the fast charging person. That's the only potential. But right now I think the infrastructure is a little expensive. I won't recommend you guys to start, like, if you have land, you start up the uh, like this charging station. Maybe if you have, like where I showed you the graph, let me show you this. Here. So see, if I'm sitting in New York, maybe I'll think about it because I'll have a lot of people who will be charging. But if you are sitting, means honestly, India right now will be this blue section where there won't be more people charging. So the best, if you really want to put up a charger, is put up a solar plant. Okay, like a solar panel, and then charge, and then don't make it free, you ask for money. For you, the electricity will be coming from solar, and that is like for 30 years it will be coming from solar, and people will come and charge it. Initially it will be an investment. I think for 4 years it evens out. But if you are planning to have a charger, uh, do with the renewable, then it'll be cheaper for you.
That means,
May I
madam,
ask,
it is like a standalone system or a captive generation kind of thing that we can implement for charging purpose.
Yeah, and that's what we are doing actually in parks and all. So see, like in this diagram, you can take it from electricity grid and then give it to charger, or you can take from solar panel and give it to charger. Okay, or you can have a battery here. So if you have an inverter, big inverter in your house, you charge from solar whenever it is too much, put it in this battery, and from this battery you give it to charge whenever the car comes and plugs itself in. So this might come handy in long run. But if you're buying from utility and you're giving, you'll be investing in charger and everything. And with the, I don't know how many users are there in your city. With limited user, you will even out maybe in 20-30 years. So that's not a good like good investment right now for you.
ma'am,
uh,
don't mind, but there is a little different scenario in, at least in Pune. There are so many
okay.
colleges, so many institutions for schools and colleges, and they have their
Uh-huh.
own buses. Right now, Pune Municipal
Oh,
Corporation has invested more than crores, 1,000 crores. They are going to invest. More
mm-hmm.
than 100 buses are running, electrical buses. Of
Okay.
course, this webinar or session is regarding four-wheelers or two-wheelers, probably four-wheelers. But
Mm-hmm.
at large scale, buses are also going to be electric buses,
Yeah,
and there are
definitely,
many
very good point.
there are many colleges and students, those who are going
Mm-hmm.
to travel by those buses, electrical buses. For them, actually, we are thinking to put charging stations. So optimization and all that, uh, probably it goes for that case as well.
Oh yeah, definitely. Then yeah, I'm sorry. I don't, like I said, I don't know your city. You know it more. I'm happy to do the data analysis for you, like, how much money and all that. Means after, after the session, you can contact me. But when I was thinking, I just read in some news that we also have some two-wheelers which are electric, like auto, and some, like, some scooters. So that might be a market too. So we have to dig in more full data analysis, and we can come up with a business model.
Thank you.
Sure. Thank you.
Okay. 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 Anybody? Any other want to ask question?
Ma'am, last question. The demographic you have shown on your America's graph. So it shows the manufacturing potential of charging like 5 kilowatt, 10 kilowatt chargers, or this is the potential of big charging stations like 50 kilowatt charging station at one point. What is this graph talks about?
So this one that I'm showing right now.
Yeah, correct.
Yeah. So this is actually the study that we did, that just on the demand, forecasting on the demand,
Of
doesn't
four-wheelers.
matter charger, anything. So number of EVs in next 5 years, potential next 5 years, and how many chargers I already have. Take a ratio that I have only 10% of the chargers I will need in 5 years from now. And
And what is the
if
capacity of those chargers?
it can be anything, it's total, add on every demand and add on every charger. That, let's say if I have 100 cars right now, and I'm thinking I'll have 1,000 cars, okay, in 5 years from now, how much ever the total load I will need for those cars to charge, how many chargers I already have in the market, either home or public place. Okay, so then divide it. So if it is just 10-20%, then you have to fill in the room for the next 90% remaining, right? That becomes your rate.
Okay. Thank you. Thanks.
Okay. Okay. Thank you, ma'am.
Sure.
So we have come to the end of this today's first session. On behalf of Peace Modern College of Engineering and Department of Electrical Engineering, I would like to thank Rekha Sharma ma'am for delivering this wonderful session. In this session, she covered about EV basics, network management, charging management system, data analytics, big data in electric vehicles, potential with AI and ML, and what are the potential risks involved in this AI. Ma'am, you have covered this session very beautifully. Once again, thank you, ma'am, and also thank to all participants. Thank you, ma'am. Uh,
Thank you. My pleasure.
Thank you indeed, ma'am, for the excellent session. How to